Right, let's look at the homework 1.1, problem number 6. Right, so we have an open rectangular box with volume 5 cubic meters with a square base. Right, so let's draw a picture. Right, so it's a square base, so it's going to look like this. So you have a square base and it's an open box. So it's going to look somewhat like that. Oops. Right, and so it's open, so we can see this, and you cannot see that, and we can see that. Right, then the volume is 5 and the base is x by x, so we have x here, right, and x there. Right, since we don't know the height, let's just call it h for now. Right, then since volume, so volume is, let's see, the volume v is equal to, right, so volume of this box is x times h. So we have x times x, so x squared h, right? And we know that this has to be 5 cubic meters, right? And I'm going to solve this equation for h by simply dividing through by x squared, right? You would have h is equal to 5 over x squared. Oh, so we have that. All right, then we want to express the surface area. So what we need to do is we're going to actually open this up. So we're going to cut this here and cut it here and there and there. And I'm going to open these guys up. So this way and open this way and open these guys up. Right, and it's going to look like this. So you have full side walls, and probably it looks something like that. Right, it's not pretty, but looks like that. Right, so we know that this is going to be x by x, so this is going to be x squared. Right, and this is going to be h right here. So all these guys have an area of x times h, so xh. Right, so if you want the surface area, so they call it SA. So surface area is going to be the bottom, so base is x squared, plus 4 times, because there are 4 side walls, xh. Right? But the good thing is you can see that the h has an expression. H is same thing as 5 over x squared. We can just plug that in here. Alright, so we're going to get x squared is x squared. And the 5 times 4 is 20. And the one of the x cancel out, so over x. Alright, so let's type it in. Alright, so what we got was x squared plus 20 over x. Right, then we want to find the domain of this surface area. Right, so this is just a physical restriction. Since x is the length, we don't want x to be negative, for example. And in this case, 0 is not going to be very good too, because x is a side of the base. So it has to be at least positive, right? So we know that it has to be at least positive, right? Then how big can x be, right? So we can actually make sure that the volume is 5 cubic meters, no matter how big the base is, because the bigger the base is, you can just shorter the box. So by making the base really big, we can actually make the box really short to make sure that the volume is still 5 cubic meters. All right, so it could be as big as we want. So it's going to be infinity. So I guess I have to look for, I guess, Greek letter. Is there infinity there? Let's see. Maybe it's a symbol. Symbol here. Infinity. Right? So that's how you find domain. And you have to be careful. This is not natural domain. Natural domain would be all real numbers except for 0. 0 is the only bad number. But this domain is just comes from the restriction, the physical restriction. So since we're talking about length, we shouldn't talk about negative numbers. So that's why we have this as the domain. Right? Let's double check. All right, let's go down and submit for testing. All right, it came back and looks like we got this one correctly. All right, that's it. I hope that this was clear.